So hello everyone, welcome to Spentarn learning platform. And this is the fourth lecture in the career in VLSI. I know it is a little bit late, but the things which is very much important for you, I have to give it time, right? So now today in this lecture, we will be going through to the Karnaugh map. So let's move ahead. So I'm your instructor Puneet Vasist, the founder of the Spentarn Doctoral and Tuition Friend, and also the ex-president at VLSI Club. The first topic for today is sum of product form, which is SOP, right? So what is directly generally asked in the interviews, that is how you can explain SOP or sum of product. So sum of product is a form of expression in Boolean algebra where various product and terms are combined together through sum, which is or we can say, right? So how we can just directly write the SOP. So this is the format how we can just write the SOP. See, one thing it is already written here that it consists of all the midterms. Remember this thing that whenever we are given the SOP, if an interview asked that what are the terms we have in the SOP, so it is the midterm, right? What is midterm? We will be knowing it in the further videos or maybe in this video only. So examples are AB plus BC plus CD. That means here we have the product and it is getting sum with other kind of variables which are already being multiplied with each other, right? So this is the format of SOP. Similarly, here is another example A bar BC plus AB bar. Now another question is that what is a canonical SOP? So it is the form of expression in SOP where all variables are present. What it means? Basically, if this example is here. You can see if we are given A, B, C and we have three variables. So in the expression, these all three variables should be present, right? So you can see in the first term we have A, B, C. In the second term we have ABC. In the third term already we have ABC. That means in all the terms of this example we have ABC or all the variables are present. So we can say this one is our canonical SOP. Now, one thing you should know while solving the questions in the Karnaugh graph, which we will be doing in this video only, whenever we are just writing the SOP, if it is given 1 or if it is given A directly, we can just assume that it is 1. But in case of 0 or in case of A bar, we can write it as 0, right? So it is for the simplification purpose that if we are given A, B, C, that means here the value is 1, 1 and 0. Why? Because A is directly given, so we'll be writing it 1. P is directly given, we will be writing 1. But C is not directly given, it is being complemented, so we can write it as 0. Similarly, in this case, A bar BC we are given, so we can write it as 1, oh sorry, 0, 1, 1, right? So in next case, AB bar C, in this case, we can write it as 1, 0, 1, right? So whenever we have the complement, we can write it down 0 in form of SOP. Remember this thing. Okay, let's move ahead. Now, the sibling of SOP is POS. You can assume it, which is product of sum. The question is being asked that what it contains generally, or how you can explain the POS. So you can directly say that whenever we just want to express all the max terms, we will be writing it as POS, or we can just assume it that it is POS format. Or directly in simpler terms, if I say that whenever we have the POS, it will contain all the max terms, right? So the definition is here. POS is a form of expression in Boolean algebra where various sum terms are being combined together through product. Product is something and, right? So here is an example: A plus B into B plus C into, or product you can say, and C plus D, right? Similarly, here is another example. Now, again, here is a same question that what is canonical POS? So canonical POS, as the name itself saying, that all the terms should be present in the POS format, then only it will be known as canonical POS. In simple words, I can say whenever I have all the variable present in the expression, right? So it is being completed, or we can say it is a complete POS, or it is a canonical POS, right? We can say, we can see here that a plus b plus c bar. That means we are having a, b, c, three variables here, and similarly in the next we have three variables, and similarly three variables a, b, c are being product together. It will be forming POS form, right? POS, right? Now here one thing you have to remember for the numericals or for the part of interview, that whenever we have a directly given here, I will be representing it as 0, but if it is given a bar, we will be representing it as 1, right? So you can say that it is the complement of SOP. Yes, because in the previous one, when we were doing the SOP, here we have a equals to 1 and a bar equals to 0. We are representing it as like this. But in case of POS format, the thing is being changed here, that we are denoting a equals to 0 and a bar equals to 1. Okay. We will be knowing it in this video only when we will be doing the numericals. It will become more easy to you understand this stuff, right? Let's move ahead. Now, so what is the basic difference between SOP and POS? So I have told you earlier that SOP generally contains all the main terms, but POS contains all the max terms, right? Now here is an example that if we are given A, B, C and the values are given 0, 0, 0, 0, 0, 0, 1, 0, 1, 0, I can represent this binary format into decimal, which is 0, this format into decimal, which is 1, again this one is 2 and 3. I hope you know this if you have already watched my first video or the second video where we have just learned that how to convert one form into another form. Now while representing it in the min terms, we all know that if the value is directly given or if it is given 0, that means we will be having the complement in the min terms, right? So you can see here, as it is a, b, c we are given, we can see here that a is 0 here, that means a will get complemented here into. So as we are writing SOP here, so min terms will be represented with SOP, but POS will be represented with max term. Okay, so let it be more clear with the help of another pen. Okay, now for the SOP we'll be using this min term, and for the POS we'll be using this max term. Okay, so here is the representation of it. So for the 000 format, for representing the 0 decimal value, we will be having A bar, B bar into C bar. It is the SOP form, right? Now for the 001, we will be having A bar, B bar into C, not C bar this time because C is 1 here. Okay, so we have write down this one. Similarly, you can write down all the values like this. Now moving ahead with the next term. In the next term, we have seen earlier that in the previous slide, as we have seen, look at here, that if it is 0, we will be representing it as 1 or A directly. Okay, but in case of 1, we will be representing it A bar, right? So let's use this one. So when we have A equals to 0 in the max term format or in the POS format, we will be representing as A, not A bar this time because it is max term, or we can say it is SOP format. So sorry, POS format. POS is what? Product of sum, right? So we'll be having A plus B plus C because these three all are 0 here, right? In the next case, when we will be representing 1 in the POS format, it will be represented as A plus B plus C bar because A is 0, B is 0, but C is 1 here. And for the 1, as we have seen earlier in this slide, that for the 1, we will be representing it as complement of that particular term. So here for the C, if it is 1, for the POS format, we will be representing it as C bar, right? So you can write down all these values here. Okay, it will become more clear to you when we will be doing the Karnaugh graph. Okay, Karnaugh map we will be doing in our notebook. So let's move to another slide, which is universal logic elements. It is very much important when we will be doing the conversion. Okay, so why we say that some logic elements are universal? So the universal gate, we know that it is NAND and NOR, right? These upper gates can design any of the other gate elements. Other gate elements means if you want to design AND gate, if you want to design NOT gate, if you want to design XOR gate, And even if you want to design NOR gate using the NAND gate, it is also possible, right? So generally we used to generate our expression using these gates only, because these gates are what? Fast and small, right? If you will be designing it with the help of the different kind of methodologies which we have, right, in the VLSI, so there we can see that it is very fast to design them. It is very small in size as well. So one thing you should know here is when we will be just designing the circuit for the SOP, we will be using the NAND gate. Okay, just remember this thing. And when we will be designing the circuit with the help of POS expression, we will be designing it with the help of NOR gate. Actually, it is not OR, it is NOR. Okay, so we will be designing it with the help of NOR gate. Okay, but generally we will be designing it with the help of NAND gate. In the corporate world, they generally use NAND gate because NAND gate is much more faster than NOR gate, and also it is very much smaller than NOR gate. So we are just dependent on NAND gate in the industries. But yes, it is also possible that you can design it with the help of NOR gate, because as I have earlier told you that if we just complement the SOP, it will give me POS form, right? The complement of SOP would be POS, and similarly, if I just complement POS, I will be getting SOP, right? So remember this thing. So we can use NAND gate or NOR gate, but generally in our corporate world, we use the NAND gate. Okay. So let's do a numerical on it. So we have to design it with the help of NAND gate because it is directly given. You can see here it is the SOP format, right? For the SOP, we all know that if we are just denoting A, that means it is directly 1, but in case of it is A bar, we will be denoting it as 0, right? So this is the thing which is to be known while using the SOP format, right? So in this case, when we will be looking at the question, it is Z equals to A bar B plus BC plus AC. Okay, now we have to use only NAND gate. Okay, for this thing, you should have to follow some steps. So first step is that design it using the normal gate. So what is the normal gate for A bar B? So the normal gate for A bar B would be that we are just multiplying these two things, A and B. We are just multiplying them. So for that we will be using a AND gate here. Similarly for BC also we will be using AND gate. A bar C we will be using AND gate. So we have used these AND gate. Now from this AND gate I will be getting A bar B, right? A bar B I will be getting here. Now for this BC I will be getting after this NAND gate I will be getting here. Now okay, so I'll be getting BC here. Similarly A bar C I'll be getting here. Now I want to add these three. Okay, you are, if you look at this plus sign, that means we will be using OR gate here. So one OR gate means we will be using this OR gate, and I will be getting Z here. It is not Z bar, it is actually Z. Okay, so we'll be getting Z here, right? So let's move to the next slide. This is the step one actually. Okay, now for the step second, what you have to do is add bubble on AND gate and behind the OR gate. Why? Because if I just use two NOT gate, bubble is something you can just assume it is similar to the inverter. Inverter is what? Our NOT gate. Okay. So if I just add two NOT gate and if I just give value A, I'm just explaining you the things why I have used the bubbles in both the sides. If I just give A, the output of this first gate would be A bar. Okay, A bar. You can say directly complement. Okay, because it is, I'm using here, it is the NOT gate or inverter. Again, it is being passed through another inverter gate, so it will become A. That means if I just giving A directly, so if I just pass it with two NOT gate, it will become A only, or we can say the similar value we will be getting at the output. So similarly here I have used these two inverters. First one is being put to the next to the AND gate, and another one is being put behind the OR gate. Okay, so it doesn't make any kind of difference in the circuit. So we have just added these bubbles in front of this AND gate and behind the NOR gate, or directly and OR gate. Okay, so this one is our OR gate and these are our AND gate. Let's move ahead. Now step 3 is that we can just replace the gate replaced, all the gates can be replaced by NAND gate. You can see in the previous slide, it is already become our NAND gate, right? I can just directly write it as or directly present it as NAND gate, because already we are just adding inverter in front of AND gate, so it will become NAND, right? So it is already become our NAND gate, but in this case we will be using the De Morgan's law. Okay, see here I am just getting A bar B, B C, A bar C, and if we just pass this with the help of this NAND gate, that means I will be getting value what? A bar C to the whole complement, right? Why this whole complement? Because I'm using here this NOT gate, or we can say this one is a NAND gate, right? And we know if we just want to use De Morgan's law, right? For an example, I'm getting A, B, C at the input of this, right? And if I have just given to complement them, what is the value I will be getting after solving it with the help of De Morgan's law? I will be getting A bar plus B bar plus C bar. Or actually just remove the third one. We can just assume directly 2, right? Or you can just assume it like this. Okay. So in the previous case, what we have seen is if we were just getting these values here, and if I am just getting here A, B, C, and if I just use the De Morgan's law, I can just directly represent it as like this one, right? NAND gate. You can see here, if I just convert it with this one, I will be getting this NAND gate, or I can convert this one into this OR gate. Okay, so this is how I have just converted it. You do not have to worry about how we have used, but just know the things which is being going on here. Okay, so how we have just replaced all the gates with the NAND gate. This is the basic question which is being asked in the interview. So we have converted this expression into the expression which is having only the NAND gate, okay, and it is Z only, it is not Z bar, okay. So now for the K-max, for the K-map, we will be moving to the notebook. So let's go.
So hey everyone, we have already discussed that what is SOP and POS form and how we can just denote the SOP and POS. Now we are moving ahead with the some kind of numericals, and we are moving with some kind of K-map techniques we will be going to understand here in our notebook. So again, I want to welcome you to the Spentarn learning platform, and here we are just discussing the things on the notebook. So why I'm just discussing these things on the notebook, because it becomes so easy for you to understand the concepts. So here, first of all, the thing is why we need the K map. Basically, to go to the K map, we must understand the necessity of the K map. So the necessity is that to reduce the complexity of our circuits, we need to minimize the expressions. For an example here, we have this huge expression, and I hope you all know in which form it is being written over here. It is SOP. What is SOP? I have already told you. Please go through to the video if you do not know. So SOP means that it is sum of product, right? So it is the sum of all the products of the terms or variables which we have, right? Now the solution here is, if we want to minimize the expression, we have different kind of concept, like we can just use the different theorems, consensus theorem we have, and we have the theorem of De Morgan's, right? So we will be using those theorems. Apart from that, the basic concepts which we have learned in our mathematics in earlier intermediate or in 10th level, right? Now we can just take out the common of C bar from our whole expression. So I have taken out C bar as common, and I got A bar B bar plus A bar B plus A B bar plus AB. Now what I have done is I have taken A bar from these two statements. So A bar I have taken, and it will just remain like B bar plus B. Similarly here I have taken A, it will become B bar plus B. One thing I want to tell you here is, if something got added with the same expression and with its complement it is being added. For an example, I'm just adding C plus C bar. What it mean? For example, if I'm just giving C as 1, what would be the value of C bar? It would be 0. And whenever I am just adding these two values with this OR gate, we will be having the expression as 1, right? 1 plus 0 is 1 always. Okay. For an example, if I want to give it 0, C bar would become 1. In this case also we will be getting the output of 1, right? 1 plus 0 we will be getting 1. So I can write down B plus B bar as 1. I have write down here, and similarly I have write down this one as 1, right? This one is in bracket. Now we have C bar outside of the bracket. Now A bar plus A I have got. So A bar plus A, similarly it will become 1 and I will get the output of C bar. So this is the necessity to minimize the equation. Why to minimize the equation? Because see here, if I want to just denote this first expression, this first equation I want to express with the logic gates, I will be getting this huge circuit. Even I haven't just used the NOT gate for A bar, but directly I have just represented that yes, we will be needed here the 5 logic gates, right? But in case when I have just minimized it, I will be just getting the value y equals to C bar, which means it will be needed the only one gate which is NOT gate, right? So I will be getting y equals to C bar directly. So I can just minimize this whole equation expression into the simpler one. So this is the necessity of using the minimization. But in case of just complex equations, if we have different complex equation which is very much hard to solve, not very much hard, but complex equation we can say directly. So there we have the need of K-map. So let's look to the K-map here. So here we are on the K-map. K-map is something like Karnaugh map. Why we use, I have already told you that to reduce the complexity of the circuit, we use K-map. To reduce to minimize the complex equations, we use the K-map. Here we do not have to reduce our direct equations. We will be using only the K-map to reduce the equation. We do not have to use any kind of theorem or something, right? So first of all, you should know that how we can convert the binary into gray code, because we will be using the gray code here. I have earlier told you in the first video that how we can do the conversion. So gray code is compulsory to know. To reduce the complexity and minimize logic or simplify the expression, we use the K-map, as I have earlier told you. Then group of 2 and common elements. I will let you know what is this. Okay. So this is for the for two variables, right? For two variables, what? That means if you have the equation like y equals to, you have the equation ab plus a bar b, right? So this equation is made up of only two variables, which is a and b. So while we are having only two variables, a and b, or b and c, only two variables we will be having, we will be using this K-map. What is this K-map? This is the Karnaugh map, right? In which we represent the values. As I have earlier told you that with the example, I will explain that why we are using this kind of stuff. So now one thing you must have to know, if I just write down the value of each particular cell, so what will be the values? 0, 0. How we can represent 0, 0? It is 0. Okay, so I will write 0 here. Now 0, 1, because I'm just writing A and B, which means I'm just writing AB into the AB format. So I will be taking A first and B second, right? So 0, 0 will represent as 0, and now 0, 1 will represent 1. Okay, so I will be writing 1 here. Now 1, 0. 1, 0 will represent 2, so I will be writing directly 2 here. And 1, 1. 1, 1 will represent 3, right? So I will write down 3 here. Just remember this thing, because I will be using it in numericals. Okay. And one more thing I want to let you know, that for SOPs we will be using 1, right, to write the expressions. Okay. For POS we will be using zeros. Okay. I will let you know with the examples shortly. Okay. Now for 3 variables we will be using. If we are having 3 variables like A, B and C, or C, D, A, something like any 3 variables which we are given, where there we will be use this kind of K-map, right? So for the A, I have used 0, 1. Now, here is the use of gray code. I haven't directly write 0, 0, 0, 1, 1, 0, 1, 1, but in case I have replaced 1, 0 with 1, 1 and 1, 1 with 1, 0. So I have used here this gray code. This is the use of gray code actually in the Karnaugh graph. But it is not that much complex. You can just generally learn this thing, that we will be using 0, 1 directly if we have 2 variables. Now If we have three variables, in case of three variables, we will be using 0, 0, 0, 1, 1, 1, and 1, 0, right? Now, we will be write down the values of each cell because it is very important before we are just going through to the any numerical or something. Okay, so I'm just writing it here A, B, C, right? And we will be representing the values here as done earlier. Now, for this cell 0, 0, 0, 0, 0, 0, what is the value of 0, 0, 0? It would be 0. So I will be writing the cell value is 0. Now 0, 0, 1, which means I will be having the value of 1. Okay. Now 0, 1, 1, 0, 1, 1. What is the value of it? It is 3, right? So see the difference. We do not have directly 0, 1, 2. We have 0, 1, 3. Okay. This is because of using the gray code. We have used the gray code here. Now 0, 1, 0, 0, 1, 0 we are using. It would become 2, right? 2. Now 1, 0, 0, 1, 0, 0 we have. What is the value of 1, 0, 0? It is 4, right? Similarly, we can write 5, 6 here and 7 here. When you will solve some kind of questions from yourself, you will just directly write like this as I have earlier write it down here. Okay. Now moving to the 4 variable K map, we will be doing the numericals on this expression generally. Okay, because this is generally asked in the interviews and to solve the equation with the 4 variables. Okay, using the K map. Now we have the 4 variables. I have write down here A, B and C, D, right? So I have taken these groups, right? So I will be writing A, B, C, D, right? We will be similarly writing the cell values here. So 0, 0, 0, 0, that means 0, 0, 0, 0, which is the value of 0, 0, 0, 0 is 0. Now 0, 0, 0, 1, 0, 0, 0, 1, the value of it would be 1. Similarly 0, 0, 1, 1, 0, 0, 1, 1, what is the value of it in binary? It is actually 3, right? 3. So similarly we can write down 0, 0, 1, 0 as 2. Now 0, 1, 0, 0, which is 4. 0, 1, 0, 1. What is the value of 0, 1, 0? If I just write 0, 1, 0, 1, what is the value of it? It is actually 5, right? Then 6 here, then 7 here, right? Now 1, 1, 0, 0. What is the value of 1, 1, 0, 0? If we convert it into the decimal, it would be like 1, 2, 4, 8. So 8 and 4, 12. We will be getting 12 here, right? Then 13 we will be getting, then 14 here we will be getting, and 15 here, and 8 here we will be getting. I think you know how we are just getting the cell values now, because 1, 0 we will be taking 1, 0, 0, 0. That means 1, 0, 0, 0. What is the value of this cell? The value of this cell would be 8. So I have write down 8 here, right? 9, similarly 10 and 11. So this is how I can represent the values of each cell. So I hope it is clear to you. Generally, the questions is being asked from the 4 variables. Similarly, we have 5 variables and 6 variables we can use by using these 3 concepts only. Okay. So let's move ahead to numericals of the K map. For the POS and SOP, both the forms we will be doing the numericals. Okay. Okay, we are here with the question of K map. Here we have given this question f abcd equals to sigma m 0, 1, 3, 4, 6, 8, 11, 15. What is this actually? So it is basically the expression which is given to us. Okay, not directly the expression. We have to make the expression, or we can say to reduce the expression, we are given this kind of thing. Okay, so we know the values are given in the format of cells. We know the cells values, and now we have to write down the values according to the cells. So one thing I want to let you know is, if you are given directly sigma m, it will denote the SOP form. SOP, that means, as I have earlier told you in the last page, that for the SOP we will be denoting the values with 1. And for the POS form, if the POS form is given, so in this question you can see sigma m is pi m is given. That means it is in the POS form. For the POS form, we will be denoting the values with 0. Okay, right? So for this question, see, we have represented the values of all the terms. Okay, all the cells we have write down the values. We know 0 would be represented here, so we have just make it 1. Similarly, we have put down the values of each cell. Okay, now what you have to do is you have to group the elements. In the beginning of K-map, we have got to know that we will be using 2 to the power n group cells, right? What does that mean? So we'll be understanding that concept here. So if any of the cell is given to you, you have to just try to make the the group of the elements with 2 to the power n, right? So 2 to the power n means 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. That means you can make the group of only one element. If it is not possible to make, then if it is possible, then you can make the two group elements. Else you will be making 4, you will be making 8, you will be making 16. So you have to prioritize 16 first. If it is not possible, then you have to go for the 8 elements group. If it is also not possible, then you can go for the 4 cells group. If it is also not possible, then 2, then 1, right? So we'll be moving with this hierarchy, right? Now here in this example, you can see starting from the 16. So 16 total we have cells. So is this possible to make the 16 cell group? No, because we do not have 1 1 1 in each of the cell. So now moving to the 8. It is possible. Is it possible to make the group of 8 cells altogether? No. Why? Because if I just try to make 1 1 1 1, here it is 1 not possible. Other case, no, it is not possible. Then moving to the 4. Is it possible to make the group of 4 elements? It is also not possible. Why? Because if I see 1 1 1, okay, here it is not possible. Now other thing can be like 1 1. I can take this kind of scenario as well, these two and these two, okay, because if I just flip the whole K map, if I just try to do this thing with this group, here one is also not possible. So it is also not possible to make the group of 4 cells, right? Moving to the 2. Is it possible to make the two cells of group or 2 elements group? Yes, it is possible. How? We can make the group of these two, right? We can make the group of these two. So I'm just coloring this with this one, okay? So we got first group. Now other thing we can do, yes, we can do other thing, which is this one. This group I can make 1 1 we have in this group, so we can make this one group, okay? Now what is the other possibility? So other possibility can be, we can just group these 2 elements, this one and this one, because if I just fold this K map, if I just try to fold this K map, these will got merged, right? So in this case I can make these 2 as well, right? Similarly, I hope you got the other one, which we can make is, we can make the other element group, which is this one and this one, right? So this is the basic concept which you should know, okay, how we have made down the groups. Now as you know how we can make the group, now you have to represent it with the expression, how we can just represent. So this is the very important thing that you should know. So to make the expression, you should have to know the values which is given for this group. If we just see this group, this yellow group, okay, this yellow group, I want to know the expression for it first of all. So for that we have 0 0 cell and 0 1 1 1. What is it? So for directly for this group, we can see for this group directly it is being attached to 0 0 for the AB, and we know in the SOP format, if it is SOP, we can directly represent AB. If it is 0 0 here, then we can directly represent it with A bar B bar. It is not completed yet because we have to check CD as well. So for this group, if we check CD, for the CD, if we check, this one is C, this one is C, this one is D, and this one is D. Now what I can do is, for the C is getting changed, C to C bar, but D is remaining same. So we will be taking D only, right? I can directly write A bar B bar D, right? Plus this group is being finished now with this expression, right? Now moving ahead with this blue expression or the purple expression. 1 1 we are having in these 2 cells, we have make the group of them. Now we have to write the expression. It is very important thing. It can be very like a long video, but it is very important to know, because if we will be doing the sequential circuit, there also you have to use this K map and these different kind of things to reduce the expressions, right? So please focus on it. Now we are just moving ahead with this purple cell, okay, these group of cell. Now 1 1 we have. Now in this case, if we take AB, now in case of AB, now in both of the case we have a common. That means I can write down a, because 1 1, a is 1 in both the cases, but b is getting changed, so we will neglect b. So what we have learned here is that whenever there is a common in the cell, that means if we are getting a in both the cells, we can directly write it down. Similarly, if we got 0 0 here, that means 0 0 is common for the a, we will be writing a bar, right? But in this case, we have 1 1 common for the a, but b is getting changed 1 and 0, so we will be not writing b, right? So we have write down a. Now for the CD case, you can see directly in this cell 1 1 is given. So 1 1 is given, we do not have to compare it, or we do not have to make any comparison with other cells, so we can just directly write down it as ACD, right? Now the work for this one is also finished. Now for this cell, this orange cell, for this case you can see 0 1 we have, and both are lying with the 0 1 in the horizontal line. We do not have to compare it with any other, right? For an example, if we were given these two, so we have to compare these two, but in this case we have only this one in which we have these this group, right? So 0 1 we have given, we can directly write it down a bar b, right? Now above we have to check CD as well. So for the CD, you can see CD is 0 0 for this one, but in this case C is 1 and D is 0. That means C is getting changed 0 and 1. We do not have to take it. And D is same 0 0. So we will be writing D bar here, right? Because D is 0 in both the cases. If D can be 1, so we'll be writing D only, right? Now the work for this one is also finished. Now this cell is left. The group of this cell is left. How we can do this? You can see if we check AB, A is getting changed 0 to 1. We will neglect that. Now for the B 0 0, it is same. So we will be writing B. Not only B, because we are just having 0 0 for B. We will be writing it as B bar. Right. Now we will be checking for CD. CD, there is only one cell, vertical cell. We do not have to compare it with other cell for the CD. So we'll be writing directly C bar, D bar. So this is the whole expression which we will be getting, okay, for this K map. I hope it is clear to you. So we have done it with the help of SOP. I have earlier told you that if given in the format of sigma m, we will be just directly writing 1 for the SOP, or it is already given that it is SOP. And one more thing I want to add on here is, if you are given SOP and you want to convert it into the POS form, what you can do directly is, you can just directly take the complement of this. And what is the complement of sigma m? It would be the values which are not present here, right? So if I want to write POS form for this one, I can just directly write it. Okay, let me take the pen. POS format I want to convert. So converting into the PS form. So what it would be? You have to just write pi m, and the values which are not present here would be your POS format values, right? So 0 we have, 1 we have, 2 is not present, right? So 2 we can write, 3 we have, 4 we have, 5 is not present, so 5 we will be writing. 6 we have, 7 we do not have, so we will be writing 7 here. 8 we have, 9 do not we have, so 9 and 10 we do not have, so we will be writing 9 10. 11 we have, 12 we do not have, and 13 we do not have, and 14 we do not have, right? So this is the expression for the POS. Okay, and for the POS we can just put the values of these whole cells to 0, and we can just simplify like this one. But the difference which we will be getting to know in the next example. Okay, so is the question given to you that this is a format, and from this first expression, from this value only pi m, you will get to know that yes, this is the POS format. So for the POS format, as we have got to know that we have to put the values of cell to 0, right? So we have put down the values of the cell to 0 here. Now if you have read very attentively to the lecture, you have got to know that while we are just writing the POS values, we have to add the values and just multiply them, right? What is that? Okay, I will let you know. First of all, we have to group the values as we have done earlier in the above question. So how we can just group the values? We can group the values in, if it is possible to group 16, it is not possible. 8, no possible. 4, yes, it is possible. So we will be just grouping these cells, this one and this one. right? So we have just grouped these cells, right? Let me color this one. Okay, it is got into the group. Okay, now we will be writing the expression for it because else it will become more complex to you. So I have earlier told you that we have to group with the elements of 2 to the power n. So we have got 4 elements common, right? Or 4 cells common. So we have make the group here. Now for the f, we have to write down the expression. So f, we can write down with the help of POS format. So how we can do that? So 0 0 we have given, 0 0 we have given. We have to compare A B first of all. 0 0 1 0. That means A is getting changed 0 to 1, but B is not changing. It is 0 0, right? As it is 0 0, what we can write? We can write it as B, not B bar this time, because we are doing it in the POS format. It is already known that we are just directly putting the values 0 0. So we don't have to make this complement in the format of POS. But if it was SOP, then definitely we have to make it complement, right? Now we have to make it plus because it is the POS format, product of sum. Okay, we will be doing this kind of stuff here. Product of the sum, what we will be get. This is the sum we will be getting, and we have to product it. So we are having this expression in the POS format. So this is how we are doing it. Now we have done with AB, but CD is left here. For the CD, how we can just get to know? So for the CD, you can see directly 1 1. That means C we are getting common, right? So we will be writing C, but not only C, it will become C bar in case of POS, right? But in case of SOP, it was directly to the C because 1 we are just putting the values directly 1, but in this case we are just putting the value 0. So in case of 1 1 common, that means it is complement of 0, so we will be writing it C bar. Okay, now in case of D, it is getting changed, so we will be not writing D here, so we can just finish this expression here. Okay, now for the second group, we have to make, for the second group I have to make the use of maximum groups, right? Or maximum cells, so that our expression can be reduced. Okay, so for making the cells group, we can have the 1 group of cell, 2 group of cell, 4 group of cell, then 8 group and 16 group. So we have to just look from 16 to 1. So we do not have 16, we do not have 8, we have 4. So we have made down 4. Now again we have 4. Which one? These two and these two, right? We can reuse the values of any other cell, right? So we are using these two values. Okay, so for these two values, or we can say the group of these 4 cells, we have to also write down the expression for it. So in this case also, as you can see, A is getting changed from 0 to 1, so we will neglect that, and in case of B, it is getting 0 0, which means it is same, and we're writing directly B here plus. Now we'll be checking for CD. For the CD, C is getting changed 0 to 1, so we will neglect that. But in case of D, it is 1 1. That means it is same for them, and we can write it down as B or D bar directly. Okay, so this is the expression for our POS format, right? So this is how you can reduce the expression with the help of K-map, right? So as you have seen that if we were using the maximum values in a group, the expression got reduced. For an example, if I was using only the two groups, let's see here. If I was using only the two groups, the expression got very huge, right? But in case of F is that I have used the group of 4 elements, the expression got reduced. Similarly, to reduce the whole expression again, we have another format, which is the don't care condition. So what is the don't care condition? We will be getting to know here. So don't care condition is something in which our system do not have any impact directly. Okay, and we can say an input output condition that never occurs during normal operation. It never occurs during normal operation, and for our simplification of our equation, we generally use them, and it is being indicated with x, right? And it can either be 0 or 1, right? Which helps in our simplification. We can just make it 0 according to our specification. For an example, if we are given sigma m here, Sigma m means it is the format of SOP. For the SOP, we generally write it with the help of 1. So we can write it down with our own specification that if it is SOP, we can write down with it as 1. But if it is a POS, we can assume it as 0, right? So in this case, we will be assuming it as 1, right? So this is what the don't care condition is. Now, we will be taking the numerical here for the don't care as well. Okay. You can see directly we have these whole values. We have to just write down all the values in this k map, right? How we got to know that we have to make this 4 variable k map if it is not given here a b c d? As in the previous question we were given a b c d directly, but if it is not given, you can just directly calculate it with the help of find out the maximum value which is given in this whole question. The value is 14. Now for to denote the 14, what is actually the binary value for the 14? For the 14, we can write down like we will be getting 1, 2, 8, and then we will be getting 16. But we do not have to go up to here. We can write it down with the help of 1, right? 1, 1, 2, 4. We have just forgot down here. So we'll be writing it as 1, 1, 0, triple 1, 0. Okay. So this is the value of 14 we can present. So here we have to require the 4 variables to denote this whole kind of 14, right? So for that we will be requiring a b c d to represent the 14 value, right, in the binary. So we got to know that yes, we have to use this 4 variable k map here, right? So we have just put down the values of the cells as 1 for the direct given SOP. But for the don't care condition, we have given D here. So we have to make it as X, as I have earlier told you. So I have write down it here as XX, right? For the 10th cell, I have to write down X. I have write it down here, right? And similarly for the 13, 14, okay, 10 values here. So I have write it down like this. And for similarly, we have write down 13, 14 values. 13th and 14th cell we have write down as X. Now we have to make the group of maximum elements, as I have earlier told you that it is the 2 to the power n group of elements or cells we have to make. So we will be starting from 16, then 8, then 4, then 2, then 1. We have to move in this direction. Now in case of 16, it is not possible to make the group of 16. We do not have each cell as 1 or XX, right? But in case of 8, can we make it? Again, no. But in case of 4, yes, we can make it. How? See, we can take this cell, this cell and this cell, right? So this group is being possible to make, right? Similarly, here this group and this group we can make. Okay. Now you will ask me that why we have left this X, because it is not having again any impact on our normal operation. As I have already told you, an input condition that never occurs during the normal operation. So it is not necessary to include that. But for the simplification or to reduce expression, as we have seen earlier, that to make our group more large or to group the cell or to maximize the group of the cell, we just need the don't care condition. So we have neglected this one because it is of no use. But whatever we have the use, we have just included them. Okay. So now we can just simplify the expression for this one. What can be the value for the AB? First of all, A is getting changed 0, 1, but B is same. So 1, 1. So we will be writing B directly, right? But in case of CD, CD 0, 0, 1, 0. C is getting changed 0 to 1. So we will neglect that. But in case of D, it is 0, 0. That means same. So we will be writing D bar because it is 0, right? Now in case of this group, you will see that for AB, A is getting changed from 0 to 1, but in case of B, it is 0, 0. That means we'll be writing B bar this time. Okay. Now for the CD, for this group, CD, you can see C is same here. So we'll be writing C directly. But in case of D, it is getting changed. So we'll neglect that. Okay. So this is how you can just simplify the K-map equations. I hope you got to know everything in this whole video. So let's move to the slides.
So thank you so much, guys, for joining this video. And I know this lecture is somehow very long, but this will clear your concept for the further videos which we'll be going to discuss in the, like, for an example, if we'll be doing the combinational circuit, there also the use of k-map. If we will be using the sequential circuit, there also we will be using the k-map. So k-map is very very much important, and for the k-map we have to understand the SOP and POS. So we have done SOP in this, POS in this. We have made the circuit with only the NAND gate, right? We have done the k-map here. We have got to know that how we minimize the circuit. So overall we have learned a lot of things in this video. I think it is very very much helpful for you. So thank you so much for joining us, guys, and I hope if you like this video, definitely this will help us. So I hope you have already subscribed to us as well. So thank you so much.